Okay, so welcome to section 10.2. In this lesson, we are still just learning how to work more with two-step equations. There are no definitions and there are no key concepts for us to talk about. We just have to see how these problems are going to go. In the first example, well, let's see, what does it say? It says to solve an equation with variables on both sides, collect the variable terms on one side and the constant terms on the other side. Okay, so in these problems, you're going to have a variable on both sides of the equation. All right, so in example 1, we are going to solve negative 4y equal 9 minus y, and then we're going to check our solution. So my goal is to get all the variables on the same side of the equation. So to do that, I notice I've got a negative 4y on the left and I've got a negative 1y on the right. But because I've got this extra term over here, I would like for this to go to the other side of the equation, just to get it out of the way. So I'm going to use my inverse operations on minus 1y, and to undo it, I can subtract I can add positive 1y. So plus y on both sides of the equation. Negative 4y plus 1y is going to give me negative 3y. Bring down equals and bring down the 9. And then to get y by itself, I need to divide both sides because, well, first, this is multiplication, so I can undo multiplication if I divide by that coefficient. So let's divide both sides by negative 3. And that's going to leave me with y equals negative 3. I'm also asked to check my answer. So if I check my answer, I will do that over here. I'm going to put negative 3 in the original equation every time I see y. And I'm going to use parentheses when I substitute. So negative 4 times negative 3 equals 9 minus parentheses. And then I have to also use this negative that comes with a 3. So you have a minus and then you put in your negative 3. You've got a double negative. So negative 4 times negative 3 gives me 12. And then when you're subtracting a negative, that's the same as adding its opposite. So minus negative becomes plus positive, and that 9 plus 3 is also 12, so it does check. So my answer is y equal negative 3. Let's look at example 2. In number 2, I have to use the distributive property to solve an equation, and we did an example with using the distributive property in the previous section. We just have more variables to deal with now. So our problem is negative 4 parentheses 7 halves x plus 1 equals 2 parentheses x minus 4. So I'm going to start by distributing these numbers to eliminate the parentheses. Okay, so I'm going to do negative 4 times 7 halves. Okay, well, negative 4 times 7 halves, the 4 is over 1, and I can reduce. I can say 2 goes into 4 2 times. So I'm left with negative 2 times 7, which is negative 14 over 1. So I can just say that's negative 14, and I need the x with it. And then negative 4 times 1 gives me negative 4. So it's plus negative 4 or minus 4. And then on the other side, 2 times x is 2x. And 2 times negative 4 is negative 8. So I'm going to say minus 8. Now it looks like example 1. So we need to get all the x's on the same side. So it doesn't, you can, if you want to add 14x to both sides, it's okay to do that. It'll just put your x on the right side of the equation. So I like having my x end up on the left side, so I'm going to subtract 2x on both sides first. And I make sure I line up my like terms so that I can actually combine them. So because there was an x on this one, I made sure I put my negative 2x directly under it to create a column. If I put it over here, I couldn't have done anything with that, with the negative 4. So negative 14x minus 2x is negative 16x. Bring down negative 4, bring down equals, 2x minus 2x cancels, bring down minus 8. Okay, The next thing I would do is, I'm trying to get all the x's together on one side, so let's add 4 to both sides. That's negative 16x equals negative 4. And my last step, to get x by itself, I need to divide both sides by this negative 16. So that gives me 1x equals, and then negative 4 over negative 16, if I simplify that, that's going to be negative 1 over negative 4. Okay, but I know a negative divided by a negative gives me a positive, so my answer, I'm getting x equals positive 1/4. And that's all I was asked to do for example 2. Let's go on to example 3. So in example 3, we are told that these polygons on the left side, the rectangle and the triangle, have the same perimeter. What is they want to know what is the area of the rectangle. So in order to find the area of the rectangle, we're going to need to solve this for x. Okay, so you can see if you look at your paper, you may not be able to see it on mine, but on your paper you should be able to see that you've got 4 inch by x for your rectangle. Triangle is 4 inches by x plus 2 by 2x. That x plus 2 is really pale. Okay? So, they have the same perimeter. So, let's kind of organize the information that we're given. The perimeter of the rectangle, what do we know about it? Okay, we're going to kind of do I'm going to do a couple of columns. So the perimeter of the rectangle, and then the perimeter of the triangle. I'm just going to write down what I was told about them. For the rectangle, my perimeter, I've got 4 inches by x, and then that would be another 4 and another x. So 4 and 4 is 8. And then I've got x and x, so that's 2x. So the perimeter of my rectangle is 8 plus 2x. The perimeter of my triangle, what is that? We've got 4 inches, x plus 2, so 4 plus x plus 2, plus this side is 2x. Okay? Let's combine like terms. 8 plus 2x, I can't do anything there. On this side, the triangle, I can do x plus 2x. That gives me 3x. 4 plus 2 gives me 6. Okay? What do I do now? What did they tell me about them? The very first sentence stated the polygons have the same perimeter. So that means that whatever that is and whatever that is, they have to equal each other. So we can write an equation. We're going to say 8 plus 2x equals 3x plus 6. So we've just said the perimeter of the rectangle equals the perimeter of the triangle. We can solve this for x. I'm going to get my x's, I want to get all my x's together on one side. Alright, in this case, I noticed that I've got 2x and 3x, so you might start by subtracting 2x on both sides. Again, make sure you line up your like terms in columns. So that gives me 8. 2x minus 2x cancels. Bring down the equals. 3x minus 2x gives me 1x. Bring down the 6. Okay? So I did say earlier, I believe, that I like having my x land on the left side of the equation, but it's not required. It's okay if it occasionally is on the right side. So I could do more work if I wanted x on the left, but if I'm okay with having x on the right, I've only got one step left. All I need to do is subtract 6 here, subtract 6 here. 8 minus 6 is 2 equals x. Okay, so my x is 2. Now, am I finished? All right, let's go back and see. What did they ask me to find? They want to know what is the area of the rectangle. Okay, so we don't have that yet. We know area of the rectangle is length times width. And they told us that we had one side of 4 and one side was x, and we just found that x is 2. So we've got 4 inches by 2 inches. So we know that the area is going to be, I'm trying to get it all in here. My area, I'll write it over here. Area equals length times width. So it's going to be 4 inches, and because we found x to be 2, times 2, so that's going to give me 8 square inches for my area of the rectangle. So that means my answer would be B. So there's the part down here if you need to see that again. Let's look at example 4. A boat travels X miles per hour from Toledo to Buffalo. The boat travels 3 miles per hour slower on the return trip. What is the distance from Toledo to Buffalo? So for this problem, we're going to need, if you recall, we have a formula for distance that states that distance equals rate times time. Now this is, I don't remember talking about it this year, so I'm thinking that you probably saw it last year. At any rate, we're going to use this to help us out. And we also need to organize our information. So what's going on in this problem? We've got a boat traveling from Toledo to Buffalo, and then it makes a return trip from Buffalo to Toledo. So those are the 2 trips that it makes. I'm going to organize this into a chart. So we've got the trip, the original trip. Okay, this was Toledo to Buffalo. And then we had information regarding our return trip, which was Buffalo back to Toledo. Alright, I can also use my formula to help me out here, because I know that, let's look at, we're given information concerning the rate, we're given information concerning the time, okay, and I'm going to go ahead and put in a column for distance. Okay, so what can we put in here? Let's read the problem. The boat travels X miles per hour. So miles per hour, that's the rate, from Toledo to Buffalo. Okay, so Toledo to Buffalo, that's the original trip, and that was X miles per hour. So that goes in for the rate. So we'll put X right there. Second sentence, the boat travels 3 miles per hour slower on the return trip. Return trip. 3 miles per hour slower than the original. So whatever that rate is, like let's say if they were traveling 10 miles per hour, then they were traveling 7 miles per hour on the return trip. So I can say that that rate, the 3 miles per hour slower, I'm going to call that X minus 3. Okay. What else do we have? In the table, you may have to look at your own paper for this. But we're told that the trip from Toledo to Buffalo, the original, took 12 hours. So we could put in 12 for the time there. The return trip from Buffalo to Toledo, they told us that took 14 hours. So that can go there. Now, they're asking us to find the distance from Toledo to Buffalo. We don't have any information to put in here yet. However, we do know from our formula that distance is a measure of rate times time. So I can multiply rate times time, that's 12x. And I can multiply rate times time on my return trip, I can say that's 14 times x minus 3. Okay. Now, to get an equation set up for this problem, what are the 2 trips? Think about it. You're going Toledo to Buffalo, and then you're going Buffalo to Toledo. Okay. It's the same distance both times. So that means that the distance for the original trip is equal to the distance for the return trip. And because of that, we are able to set up an equation where this distance equals this distance. So we want to solve the equation 12x equals 14 times x minus 3. Okay? If we solve this for x, we'll be able to answer the question. Now, I know that I can distribute 14 on this side, so I've got 12x equals 14x minus 14 times 3 is, what, 42. Okay, I can subtract 14x on both sides. So I have negative 2x equals negative 42. And then I can divide both sides by negative 2. And that gives me 1x equals positive 21. So I got x equal 21. Now what did x represent? I've got to go back and check what it's supposed to be. They told us that x is the miles per hour from Toledo to Buffalo. So that means this value in the table is the number we got, 21. Okay, so we got 21 for that one. What are they asking us to find? They want to know what is the distance from Toledo to Buffalo. So we need to find 12x. So 12 times 21. 12 times 21 would give us 252. Okay, so we're getting 252 miles for our answer. I'm totally out of space here. 252 miles is the answer I got. And that was it. The distance from Toledo to Buffalo is 252 miles. All right, so with this information, I want you to try the problems that are circled on your packet. And again, use my book to check your answers and let me know if you have any problems. And that's it for section 10.2. There will be another video for the 10.2b section. All right, what does it say? 10.2b, solutions of linear equations. All right, so